Hi, and welcome to Unit 7 of Statistics class. And today I'm going to be covering ANOVA. And so last week we covered t-test, where we can only look at two groups and see if they are significantly different between the two groups on a DV, or look at one group across two DVs, measuring like a pre and a post test. And so we're going to expand a little bit this week to talk about ANOVA, where now instead of just two groups, we can have several groups within an IV. And we refer to these groups as levels. So you can have more than one IV in an ANOVA, which we'll cover next week in two-way ANOVA. So a two-way ANOVA means you have two IVs. Let me start sharing my screen too. So two-way ANOVA would be two independent variables, and a one-way ANOVA is one independent variable. And within each of these independent variables, you can have multiple levels. With a t-test, you can only have two levels. So now we can look at departments, ethnicity, or anything where we have more than two levels. But you could also do a one-way ANOVA the same as you do a t-test, and you'll just get different, the results will be the same with whether it's significant or not, but you'll either get a t value or an f value. So you'll just get different statistics. Now, so when would we use an ANOVA versus a t-test? So, we can only, in the situation I just described, but also if we need to run multiple t-tests, instead of doing that, which would increase our error rate, we would want to do an ANOVA. So instead of doing a t-test between accounting and finance, marketing and sales, marketing and finance, and so on, that would be an unethical use of t-test. We would want to do an ANOVA instead and look at it all together so that we're not jacking up our error rate. Okay, so what are the assumptions of a two-way or of ANOVA? It's that it's normally distributed. The variables are normally distributed, which you check with skew and kurtosis, and that we have homogeneity of variances, which you all know we check with Levene's. Are the standard deviations equivalent? And some real life examples of when we would use ANOVA are training evaluation, surveys, selection, or performance. And I think one thing that's important to understand is I talk about your variable can be categorical, but this allows you to have a qualitative independent variable and a quantitative dependent variable. So not only is it categorical, the number doesn't have to mean anything, just making sure that's clear. Now, there's two designs for ANOVA. One is between subjects, which is like our independent t-test where we compare between groups. And the other is called within subjects, which is a repeated measure ANOVA and like our paired sample t-test, where we're measuring the same group at different points over time. Okay, now the effect size for ANOVA is called the eta square or the partial eta square. And SPSS will just give you the partial eta square, which you're lucky because the partial eta square and the eta square are exactly the same thing in a one-way ANOVA. The only difference is the values at which you interpret a small, medium, and large are different. So if you run a one-way ANOVA and it gives you a partial eta squared, your small effect is 0.01, your medium is 0.06, and your large is 0.14. And these are in your lab notes right here, for eta squared. For partial eta squared, it's now a 0.05, a 0.1, and a 0.2. Okay, so we're not going to worry about this because we're not going to calculate this by hand. All right. Now, the other important thing to know is that we're going to run some post hocs, and these post hocs are specialized types of t-tests. We're going to run two types. We're going to run an LSD, or the least significant difference. And I like to remember this as it is the most liberal. So LSD, most liberal. Donut C is what we run when our Levene's is significant, and it's much more conservative, and it's for when we have violated this equal variance assumption. So if our Levene's test is not significant, we use LSD. If it is significant, we use Donut C. Okay. And again, we're going to have an F value instead of a T value, but everything else should be roughly the same. So this is just a general overview to ANOVA. So what I'm going to do is read you this scenario. We're working in a training department for a major manufacturing company. The company is migrating to a Linux system because it's dissatisfied with Microsoft's operating system. Because employees need training on the new operating system, you have found several off-the-shelf training programs that use different instructional methods, web, video, and classroom. Your company decides to pilot these training programs at headquarters to determine which method is most effective before rolling out the training on a larger scale. You conduct training and collect productivity scores for employees. You're going to run a one-way ANOVA on the training data set. So here we can see this is not set up correctly. We've got Linux productivity. This is letting me know it's 0 to 100. I'm just going to change this. So it looks nice. Here we have male and female. And I'm going to just put it in our, and I'm actually going to say men and women. And this is something you will get counted off for in your homework in the case study. In APA, we don't refer to people as male and female because that's adjectives. We would refer to a male or a female rat or a male or a female dog. But when it comes to people, we say that it's men or women. So that's the most appropriate, respectful way to refer to people. So I'm going to change this to men and women. And then here, I'm going to change it to 0 equals web, add, 1 is video, and 2, and I know this, but you could open this up and see more, is classroom. I'm going to hit OK. Now, I'm going to change this to training method. I'm going to change this to gender. Okay, so in order to run an ANOVA, we're going to go to Analyze, General Linear Model, Univariate. And here, my independent variable that I'm being asked about right here is which of the training methods should we use? And so I'm looking for a difference between the training methods. Those are my groups. So that will be my fixed factor, and I'm going to move it over here. Now, my dependent variable is this Linux productivity, because that's what I care about. People being good at, that's what I'm measuring here. Okay, I know there's other variables in here, so it's important to know which one's your IV and your DV. Okay, and then under options, we are going to click descriptive statistics, which will give us the mean, estimates of effect size, which gives us our partial eta squared, and homogeneity test, which will give us our Levene's test. So make sure those 3 are picked. Okay, and then for post hoc, we're going to move training over, and we're going to select LSD up in this top left corner and Donut C down in this bottom right corner. Make sure you don't click Donut here because that's not the one we're using. It's the Donut C. I'm going to hit continue. And if you You can also move the means in the options. I don't do it because it doesn't help me, but you can do that. It says to do it here. And then we're done. And we say, well, and we can also do a plot. You can just move training over to the horizontal axis and click add, continue, and hit OK. All right, so what we have here, and now I'm going to make this big. Luckily, we have 30 in each group, which is good. Remember, we need that for ANOVA. And we look here and we see the web and the video means are pretty much the same. And classroom is way lower, right? And this is in keeping with what we know, that people learn more hands-on than by just listening. Now, our standard deviations are 10, 12, and 16. They're a little different, but we come down here and our Levine's is not significant, right? It's above the 0.05 level. So we will be interpreting LSD. And then here, we have our F test. So we're going to go to the line. I'm going to double click on this so it's obvious. We're going to go to the training line. This is the line we interpret. And our degrees of freedom is 2, and we always go to the error for the second one, which is 87. Our F is 12.77, and our significance is less than 0.001. Our partial eta is 0.227, which is definitely a large effect. So what this F test tells me is that there is a difference between these three groups, but the F test does not tell me where. So let me write up this first part. Let me see here. All right. So if I write this up, you know, writing your introduction and why you're doing this and what the independent variable is, we would say there was a significant difference between training groups, comma, F, and my degrees of freedom is 287. So here you have two numbers. You have the number from the line you're reading and the number from the error line. And so you're always going to report it that way. And my F equals 12.77, and I'm getting that from right here in the F column. And my P is less than 0.001, and I'm getting that from right here in this column. Now I'm also going to say, and I can't do the symbol in here, but partial eta squared is equal to 0.23. And then I'm going to say this is a large effect, just stating whether it's small, medium, or large. Okay, then I'm also back here, I'm going to put just a little asterisk. And then at the bottom of my report in the footnote, I'm going to write, whoops. Levine's was not significant. And here I'm going to give the information to, whoops. And it's 2.61. Whoops, 2.61 comma P is, I could say greater than 0.05 or equal to 0.08, letting people know it's kind of close. Okay, now I got all these numbers for the Levine's right up here. Here's my degrees of freedom, 2 and 80, whoops, 87. My F value is 2.61 rounding up, and this is where I got my P value. Okay. Now coming down, let's see, where was the difference? Now we know to interpret LSD because Levine's was not significant. And the difference between LSD and Danette's is that LSD is going to print out the P value. And Danette's is not going to give you the exact P value, but it's going to give an asterisk and let you know if it's less than 0.05. So you might go, oh, I can't find it, but this is where it is. So here, between web and classroom, between web and video, there's not a significant effect. Between web and classroom, there's a 14, almost 15-point difference. It is significant. Between video and web, not significant. Between video and classroom, significant. And then you're going to see it again, just backwards, subtracted. So what I would do here in my write-up, which I'll just continue down here so we can see this. There was a significant difference between web training and classroom training. P is less than 0.001. There was also a significant difference between video and classroom training. P is less than 0.001. Now remember to do APA for all this. Now what I'm going to do is I'm going to go back, and when I say web training, I'm going to put the mean and the standard deviation in, just like you did last week. Whoops. And here. And you're going to do the same thing over here with video and classroom. Okay, so that is how you would interpret an ANOVA. And your job before you come to class is to recreate this output and do a title and practice writing this up so that you're ready to do it when we come to class. And last thing is, here is a plot of what it looks like, the different points. So it's easy to see there's a significant difference between here and here and between here and here. Please let me know if you have any questions.